Now let us solve another problem, the group anagrams. So let us read the question. Group anagrams. Given an array of strings, group anagrams together. So I think anagrams are those strings which have the same frequency of characters. A, T, E, E, 18, T, E, A are the same anagrams. So we want to return the anagrams. All the inputs will be in lowercase. The order of your output does not matter. Okay. So we want to group those strings together which have the same anagram, right? So how we will approach this question? So let us say we have this string, right? So to start with, uh, so let us say, so there is so the quadratic approach is quite easy, I guess. So the given string, I will try to compare each one of them. But I think, is there any better way to do this? So what I can do is, mm, since they are just anagrams, so I just need to take care if they're anagrams or not. I just need to. So I think there is another approach which I can do is let us sort each string. So let's say if we sort each and every string, then I think we will be able to do this in kind of n log n, I guess. So let's say after sorting, this will become ATE, and this will become ATE. This will become ANT. This will become ATE. This will become ANT, and this will become ABT. Now, after sorting individual strings, let us sort the entire group of strings. So all the ATEs will come together. So in this way, I can um, use this sorting approach to find out the anagrams in, and we can reduce the complexity. Why? Because for sorting each string, let us say the length of the string is n. Let us say that the variable n, which denotes the length of the vector and also the length of the string, is same. In that case, my approach would go for to analyze the complexity. What I can do is I am looping over all of them, and then I am sorting each. So if the k is the length, maximum length of the given any given string in the vector, then n log k log k would be the sorting time complexity multiplied by the n. So I think after sorting, we will also sort the entire array. So that would bring this complexity to this level plus an operation of n, right? So I think this is the complexity of that we are currently talking about. So you can see that there is a factor of n into k. But I think this is better because if I will brute force, so let us say if we create two for loops for solving this question, then the complexity would be, so first of all, let us say we are currently pointing at the ith element of the string. So we will hash it and find out the frequency of the current string, and then we will compare it with each and every string which is ahead of it. So we will start from I plus 1 up to the last index, and that would and hash each and every string. So that would bring the complexity to order of n square. So instead of order of n square, if n and k are of different lengths, then obviously this of first one will be very much optimized as compared to the second one. But if it is given that both of them are of same length, as in the number of strings in the vector will be equivalent to the number of, like, so if the upper bound is same for both of them, then the second approach will be of so basically in this case, even in this case, when I'm doing the hashing, I need to count. I also need to loop over the length of each, right? So that we have forgotten to uh, consider. So basically over here, in each and every case, I need to hash a certain string. So hashing will take another k factor. Why? Because we need to travel each and every character over here. So this would be plus this is the time complexity plus we also need an auxiliary space complexity for storing the hashes of the characters. So this is so now we can say that this approach is more heavy, more costly as compared to the previous approach. So let us go with the previous approach. And if we will later figure out, so we have the solution section open, we will later figure out if there is any better way to do this, then we will surely try to do that. But let us say we start to sort. So for let us say we have this string vector over here. So let us say that the length of this vector is n. And first of all, let us check if n is empty, or let's say if n is less than, let's say n is empty. If n is empty, then we will return an empty set, right? So second thing is, so if n is equal to zero, then let us start to sort each and every string. So for n I equal to zero, I less than n, I plus plus, and we have to sort. Let us say strs of I dot begin strs dot end. So we are sorting the array over the current. Then after this sorting is completed, we also need to sort the entire str vector. Okay. So so I think we need to create a local copy because we need to return the anagrams, right? So if we will sort it, then we will lose the order of the anagrams. So I think if we want to do this, there will be an additional operation of n into k to find out if which are the given anagrams. So how will we optimize this? So because what we are going to do is, so we have sorted each and every anagram, we have sorted each and every string, and after the sorting, we are saying that this string has three anagrams. This, so we will group them, but I think along with this, so let us say this str's array, this string that we have sorted. Um, okay, so I think what we can do over here is we can create another vector which contains a pair of string, right? Which contains a pair of string, and let us say this vector is v, and for string I in strs, what we are doing is we are pushing both the same string inside it, right? So what we are doing is we are pushing I and I again, and then when we are looping over here, we will say v of I dot first. We will only sort the first, right? We will only sort the first string, and then once we have sorted the first string, so now we will sort this vector, right? So I think now it is clear. So now let us say we have to store the answer in uh, this vector. So what we will do, we will start looping, right? So let us say we start to loop from this, and let us say there is a vector local, right, which has this key, right? So if v of I dot first is equal to v of I minus one dot first, if this is the case, then what you need to do is you need to say local under local dot push underscore back, and you need to push back the now you need to push back v of I dot second, which is the original string, right? And if it is not the case, if these both are not equal, that means uh, the current session of local has been ended. We will push local inside, and we will clear local, and then we will push v of I dot second into the page, right? And after everything is completed, I think now we can return answer. So let us try to run over a sample test case and see if there are any failures. Okay, so there is a failure over here because we have to write v of I. Also, there is another failure over here because I think this is wrong. So this is not allowed. Answer. Okay, so this is v of 0 dot second. So we are saying getting wrong answer. Why? Because my output is BAT, ATE, EAT. Okay, I am not getting NAT and TAN. So why am I not getting any output? Okay, so it might be possible that over here local might not be empty. So what you do is if not of local dot empty after returning everything, you might do these two steps. This is not needed. Now try to run. Now it is right. So then quickly if we will pass, we will analyze the space and the time. Okay, so we have passed it in the first go, 54 and 78%. So I think it is of not much use, but let us quickly analyze the time and the space complexity, right? So basically we are creating a pair of strings and then we are sorting each string. So obviously the space complexity will go of order of n, right? So the space complexity is now order of n. Now, second thing is, so we are doing the sorting, so this holds true. And already we have analyzed the space complexity, time complexity for this solution. So let me proofread this and into K. So what we did, of this is the n log n step. And after that n log n step, I think we do not need this n into K step right now. It is just order of n step because we are just calculating the answer, right? Yeah. So I think in this way, this is the overall solution, which I think should be the optimal solution from the interview perspective. But let us see the solution to get more clarity. So categorized by sorted string is the first approach. Intuition is two strings are anagram if and only if their sorted strings are equal. So this is what I have done. Okay, so we have not maintained a map, so where each key k is a sorted string and each value is the list of strings from the initial input where, okay, we have done something similar. So this is the string. So what we can do is, okay, so I think, yeah, this is much more better because over here we will be maintaining keys where only which are only the anagram. So we are grouping them over here only. So let us say, so what we will do is we will sort each and every string and we will maintain a map and we will just append it to the if the sorted. So we will append the current string just to sorted over string in the map. So that is quite. So this approach was very easy. I think this so n k log k is the time complexity as we have analyzed over here as well. N k log k should be the time complexity. Where n is the length of the string and k is the maximum length of the string in str, the outer loop. Okay, so I think this is, and space complexity over here is order of n into k. So let me analyze the space complexity in my case as well. So what we have is a vector answer, and we are pushing not we are not pushing integers or characters. We are pushing the strings of length k. So I think space complexity of mine is also n into k. So categorized by count. So what we currently do is we categorize by sorted string. So is there, so this is approach one. Generally, if it is approach one, that means we have further more optimized approach down. So let me see if the time in the space complexity. So the time complexity is n into k, which is improved version, right? And the space complexity was also n into k. We do not care about the space complexity, but we can improve this log k factor. So and the hint is that we should categorize by count. So what is this categorization by count? So I actually, the one approach that was coming to my mind is to group this into the using the powers of two, right? So let's say it is, if it is EAT, then I will write it as E. So basically, we will write A as 2 into the, so 2 to the power 0. So in this way, Z would be written as 2 to the power 26, and then we can sum this up. So this is a kind of way hashing function that I'm trying to create. The basically I was not sure whether the hashes will be unique in this case or not, but I think the hashes would be unique because if I'm summing up, so let us say I'm summing 2 to the power. So since this approach is now clear, I think we should erase this and try to do this in a more better way. So let us say we are erasing this entire approach, right? So yes, so let us try to use, let us try to prove that our hashing function will not collide. So let us say we have each, then what I will do is 2 to the power. So let us say e is 5 and a is 1, and let us say t is also something. But for our simplicity, what I want to make sure is if I'm summing two different series of twos, then it should not give me the same sum, right? So if I am doing 2 to the power 1 plus 2 to the power 3, then answer is 2 to the power 3 is, so it is 10. So is it possible to get 10 from another sums of twos, right? So let us say if it is possible to get this using 2 to the power x plus 2 to the power y, right? So we need to prove that these two are, these x and y cannot be any other solution except 1 and 3. If we can prove this, then I think we can use an into k approach to do this, right? So let us say if this solution exists and it is not equal to 1 and 3, then obviously let us assume that x is smaller. If x is smaller, then obviously we can bring 1 2 to the power x as a common, and we can write it as 2 to the power y minus x, right? And if this is equal to 10, right? So if this is equal to 10, so obviously we will bring 2 to the power x out. So if this is equal to 10, then 2 to the power x, then into something. So 10, so 2 to the power x must be a factor of, must so 10 must be divisible by this factor of 2 to the power x, right? And also, 2 to the power 2 to the power y minus x should equal to, so we divide 10 by this 2 to the power x, and once we get the result, we subtract 1 from it, and this should be 2 to the power new number. So let us say that it is, yeah, if we generalize it, let's say we have the number p over here instead of 10, then it might be possible that a number p has a power of 2 which is greater than x, right? So in that case, so let us say that p is equal to, let's say 2 into some power q which is greater than x, right? And also it is multiplication of some other numbers. Let's say it is also multiplication of 3 into some power q1, right? So in that case, and we are taking the case when q is greater than x, right? So in that case, this will simplify out because 2 has to be, so because p has to be the multiple of, so it can be greater than or equal to x, right? Yeah. So once we have done this, 2 to the power y minus x, right? So what we will get is we will get the power of 2 as q minus x, right? So if we prime factorize p, then we will get the power as minus x. So what we want is after this p should always be an odd number. This number should always be an odd number. Then we will subtract 1 from it, then it will get even by, because we want this. So how can we prove that this is unique? This y and this x are unique. So if they are not unique, then there is another solution y1 and x1 which satisfy this condition that p divided by 2 to the power x1, right? Now, if they both satisfy this condition, then if we take log and subtract both of them, then everything will come in to divide. So basically, instead of doing it mathematically, if so I think I am confused over here in the mathematical expression. So let us try to take hint from the solution if they have shown us mathematically if it is possible. The two strings and anagrams and only if the character counts respective numbers of occurrences of each character are the same, we can transform each string as into a character count consisting of 26 negative integer, non-negative integers representing the numbers of A's, B's, and C's. We use this count as the basis for our hash map. In Java, the hash table representation of our count will be a string delimiter. Okay. Okay, so they are saying me not to use any kind of hashing function, but to arbitrarily specify the count of each and every character, right? So basically, I will count how many A's are there, I will count how many B's are there, and then what I will do is there are 26 entries total. So yes, what I can do is instead of sorting, I can brute forcefully count how many strings are there, how many counts are there of each and every character, and we can use a delimiter as literal as the hash, this hash, and I think this is easy now. Why? Why? Let us quickly implement it to see how this is more easy than what we were thinking. So let us see. So for int I equal to 0, I less than n, I plus plus, what I will do is, so let us say we want to store the answer. So let us see that the map, we have this unordered map. So do we need any ordering? No, we do not need any ordering. So let us say we have this string, comma, vector of string, right? Let's say this is V. So this is, let's say, MP, right, map. So now what we want to do is, so let us say we are iterating over all the strings. So we have iterated over all the strings. Now what I need to do is I need to find out the count of each and every character, right? So let us make an so let us make an array of, let's say, count, let's say this array which will count each and every character, right? So let us say we represent A as 0. So now what we will do is for int j equal to 0, j less than, so we have this string str's of I dot size and j plus plus. We will iterate over all the characters in the current string and we will update its counter, right? So what we will do is we will update its counter. So let us say this is the character and let's say we subtract a from it and we, so initially we need to initialize it with 0. We have initialized it and then we are incrementing its count. So now I know how many count of A is there, how many count of B is there. So now what I can do is for let us say we are going to create a string t, right? And what we will do is for character, let's say we are counting each and every character. For character j equal to a, j less than equal to z, and j plus plus, right? So we are getting the character from here, and what we will do is we will append this, and we will append this character with its count, right? So let us say what we are doing is we are first of all we are pushing back this character, and then what we will do is we will push back how many count do we have of this character, right? So that might be a string. So what we will do is so t plus equal to, so we are appending two different strings over here. So we need to do this. We need to convert this character count into a string. So we have converted let's say ct of j minus a, right? So we have converted this into a string, and we can use a delimiter, but I think delimiter is not needed. Or is it that we need a delimiter? No, we do not need any delimiter, I guess. Why? Because let us say A has a count of 3, then A3 will be there, then after that B will come and then B will give me some count. And if this count exists in the map, right? So if mp dot find this t is equal to mp dot end, that means this is not yet encountered. So we will make an entry in the array using this. So we will say this is the version, and then since this is a vector, so we will do push back. And what we will do is so this is a vector, so we will store the string which is present at the ith position, right? And if it is already encountered, then it is more easy. Then also this same step goes. So I think we do not need to check if it is present or not. We just need to use this step, right? Now, once we are done with this, what we can mp dot, right? So once we are done with this, we need to create answer. So let us say this is the string answer, right? So for now, we will iterate over all the keys of the map. So let's say for auto it iterator, when the map, so id dot first will point to the first, id dot second will point to the second. So I will just not care about what is present in the first. I will just push the second version over here, and I will just return this second version. I think this should work. Let us try to submit. It has passed sample test case. Okay, so this is also submitted, but runtime and memory both the consumptions are very high as compared to our previous solution. It is almost double, but the runtime should have been reduced, but it is not reduced. So let me check if there are some errors from my end. So using an unordered map is always beneficial. Let us try with an ordered map and see what the outcome is. First of all, let's create a test run. Okay, so the time complexity is getting more higher. So I think this is because the length factor is not playing much important role over here. So this log k, but still this n log n, this is optimized. So the time complexity in our case is nothing but n into k, right? Over here we are okay. So this might be no, this is not an issue. This might be an issue because this might take some time. So how can we append two strings? So let us see what is the uh, time complexity of append in C++ strings. Of append as for strings of size m is m into n complexity, right? So basically what we are doing is we are creating the string, and string length can go up to k, right? And the counter variable can have, so this operation will cost us a total of order of k length, right? And this we are iterating for all the 26 counts. So I think this should not be of much importance to us currently, but yes, I think for C++, the current previous version was far better than the current version. I hope the solution is clear and we have discussed the optimal approaches. Now let's focus on the next question.